In the previous movie, we matched the IK arm to the result arm and developed a simple UI for performing our matching tasks. In this movie, we'll factor joint scaling into those matches. Open the file Character Rigging, Appendix A, Part 3 Start, and load the Match App script into the script editor, or use your own files from the previous lesson. Although our script performs admirably when the arm joints are their default length, notice if we stretch the IK arm and then attempt to match the FK arm to it using our MEL script, it can't meet the requirement. Conversely, the IK arm appears to work, but a closer look reveals that although the elbow control is in the right spot in the scene, the actual ratio of upper arm to forearm length isn't correct compared to its FK counterpart. We'll need to fix both these scenarios if we truly want our script to be bulletproof. Let's start with matching the IK arm's scale to the FK arm. While the arm can match a uniform scale properly, it doesn't handle non-uniform scaling between the upper arm and forearm quite as well. If you think about it, this type of scaling is really only handled by our rig in one way, via the elbow snap control. When you enable elbow snap, the upper arm and forearm are forced to scale in order to snap to the elbow control's position. So all we need to do is turn on the elbow snap when the length attribute of the upper arm and forearm joints aren't their default values during an IK match. Remember that the default length of the upper arm is the forearm's default translate X value. Likewise, the length of the forearm is the hand's default translate X value. Let's store them in a couple of variables in our script's left arm IK to result procedure. Create a variable named default upper arm length and give it the default value of the left forearm result joint's translate X. Create a second variable named default forearm length that stores the left hand result joint's translate X value. Float refers to the variable's type. In this case, it indicates that these values are allowed to be decimals. Let's also create a pair of variables that store the current value of the result joint. You can use the getAttr command to query your scene for these attribute values, but don't forget to put the tilde signs around each command. Now we'll use these variables in a conditional statement. We need to test if the current upper arm's length is not equal to the default upper arm's length, or the current forearm's length is not equal to the default forearm's length. If either of these conditions is true, then we'll want to turn on our elbow snap control. Test this modified script by stretch posing the left FK arm and then matching the IK arm to it. However, notice what happens if we set the limbs back to their default length and match again. The elbow still snaps. The problem is that the getAttr command we're using actually returns much more accurate values than what is displayed in the channel box or script editor. Therefore, while the values may be very close, they are not equal. To account for this, we're instead going to subtract the two values and look at whether the difference is more than some nominal amount. We'll call this nominal amount the tolerance, so let's create a variable for it and set it to 0.001. Now we'll alter the if statement by subtracting each pair of values and checking if either of the differences is greater than our tolerance value. We'll also need to use the abs or absolute command here, because if the current length is less than the default length, we'll get a negative number, which will throw off our comparison. Run the script again. Ensure that the IK elbow snap is turned off and that the FK limbs are at a length of 1. This time after matching, the elbow doesn't snap. Copy and paste the new script material into the right arm IK to result procedure, invert the default length values, and change the left references to right. Now we can move on to properly matching our FK length attributes to the IK arm scale. Since the FK length attribute is actually a factor of the default length, we can easily calculate it by dividing the current length by the default length for both the upper arm and forearm. Copy and paste all the length variable assignments to the left arm FK to result procedure. Instead of using these in a conditional statement, however, we'll use them to calculate the length factor for both the upper arm and forearm. Create a new variable named upper arm length factor and set its value to cur upper arm length divided by default upper arm length. Do the same for the forearm. Now set the FK upper arm and FK forearm's length values to these length factors using the setAttr command. To test this, go to IK mode and turn the elbow's snap attribute on. Now position it such that the upper arm and forearm are obviously different from their default length, and click the FK left arm button. The FK arm matches. Before we copy this functionality to the right arm, there's one last issue to deal with. Switch the left IK arm to FK forearm mode, then pose the FK arm and match the IK arm to it. The IK arm can only match it up to the elbow. We should really give the user the option of snapping to this position in either IK or FK-IK hybrid mode. We can easily accomplish this by combining our solutions together. First, let's create a group of radio buttons for the animator to specify which mode to snap in. We're going to do this by adding a new row layout around our left IK arm buttons with two columns. The first column will contain our button. The second column will contain a vertically arranged radio button group. With a pair of radio buttons labeled IK forearm and FK forearm. We'll assign this first one the name left forearm mode. We'll also set the select flag to 1, which will activate the first radio button by default. With so many layered components, we now need to start making use of the setParent command to specify where one layout stops and the next begins. Repeat for the right side. Next, in order for our IK to result procedures to know which radio buttons are active, we'll create a parameter in these procedures. Think of parameters as special variables that allow us to pass in values specified outside the procedure itself. Navigate to the left arm IK to result procedure and add the following line. This will represent the currently active radio button value to be passed into our procedure. To actually pass the value to the procedure, we'll need to add it to our procedure's reference in the button command. We retrieve the value by using the same radio button group command with a query flag, much the same as we did with the xform command in the previous movies. Now let's alter the procedure to make use of the new information. If the animator requests an IK forearm, a value of 1, then we can run our existing solution. So let's encapsulate it in an if statement to reflect that. We'll also turn off the FK elbow blend before setting any new values in this case. And move the variable assignments specific to this solution into the conditional statement. If the animator requests an FK forearm, a value of 0, we need to do a little more work. First, we'll turn on both the elbow snap and blend. Borrowing from our IK forearm solution, we'll want to query the current location of the elbow control. And borrowing from our FK solution, we'll want to query the rotations of the FK forearm, as well as the length calculations. Now, once again, borrowing from our previous IK matching solution, we'll want to move the elbow control. And borrowing from our FK matching solution, we'll want to rotate the FK forearm and set the length factors accordingly. Remember to modify the script to rotate the FK forearm and not the FK arm. Finally, since we'll need to change to IK mode in either case, let's move it to the bottom after both solutions. Now we can snap back and forth between all our modes. Repeat the process to give this functionality to the right FK arm as well. This completes all the snapping functionality we need for the arms. In the next movie, we'll address the IK-FK matching controls for the leg joints.